So let's pick up where we left off. Just as a quick review, we talked about different types of data, right? Numeric, string, Boolean, and we said there's also non that you see in Python that comes up. Dates and times, I briefly mentioned them later on when we work with data sets. Hopefully we get into dates and times and we work with them more in depth. We talked about control flow commands. I don't go into those. We were talking about data structures. I talked about tuple. We were halfway through list, I think, the last class. And then we'll talk about dictionary. Set is something that is available in Python. I'm not going to talk about it. As someone who was very experienced programmer, is always telling me that sets are very underutilized. Practical, but we don't really use them in data analysis. So if you do Python programming, I put a list there. You can take a look at it and go into more details about what that is and how it works. All right. So let's pick up where we left off on list. So I talked about tuples, and I said the only thing about tuples is that at least the big difference between tuples and lists is that tuples cannot be modified. Once you define a tuple, it's just going to be it. You cannot change an element in tuple, right? But at the same time, that's a good thing because they use less memory. So if you want to define some kind of vector that is going to be fixed, you can use tuples. We talked about tuple within tuple or nested tuples. We talked about unpacking tuples. And then we start talking about lists. Now, the big difference, what's this? The big difference, let's see that. Maybe it's better if I keep it so you can actually see the main stuff on that. And let me. The main difference between a tuple and a list is that list you can modify, right? You can define the list at the beginning and you can add elements to it. You can remove elements from it. So that is more like a typical vector you have probably in MATLAB or something you define in R. And that's more similar to that. I think we went over this referring to different elements, and I said, of course, a list. Elements in a list can be any type of variable. Can be a string, can be numeric, can be non. You can have a list within a list. You can have a tuple within a list, and the other way around. You can have a list within a tuple. Or the way, depending on what your problem is and what you're trying to put into a vector. We can modify the list. All right, I define the list, and then I change the second element in the list. And remember, we said in Python, counting is started from 0. It's like Java, not like MATLAB. Right? So just something to keep in mind. So you can change any element in a list. I talked about range, so I'm not going to go back into it. Trying to think where were we. I think we talked about range. We talked about insert and pop. We talked about concatenating two lists. If I didn't, stop me because I'm just going and looking at these. We talked about sorting. Did we do this question? We didn't do this question, right? I don't remember honestly. I don't think we did that question. So maybe we're somewhere here. So let me start from, maybe you just go quickly over the list. So you can define an empty list, right? Another difference between a list and a tuple, you define a list with brackets, you define a tuple with parentheses. Right? So whenever you use bracket, it means you're defining a list. You can define an empty list. You can add things to a list. So there were two ways of adding components to a list. Right? One way was to use append if you want to add one element at a time to the end of your list. The other way is extend. And extend is the case when you want to add multiple elements to your list in one, I would say, one shot. Yeah, I'm a little disoriented here. I'm trying to remember. We did talk about range. When we talked about for loop, I think I talked about enumerate, and I said, so you can convert anything to a list with list command, right? If you have a tuple, you can convert it to a list. So one way of programming would be define something fixed as long as you don't need to change anything in it. Just keep it as a tuple. Anywhere in the program you want to convert it to a list, or you want to modify it, you can just use the list command and convert that tuple to the list. I think I mentioned insert as another method. Remember, we talked about method. We said any object in Python comes with a set of methods or attributes. Right? When you put the list name of the object, press dot, put dot there, it gives you a list of possible options for your attribute or methods for that object. In this case, we have, in terms of the list, you have pop, which basically removing the element in your list. Pop.pop2 basically removes the third element from the list. And you have insert. Insert adds an element to your list. Right? So in this case, I'm saying I want to add the element or this value or this variable red, the string variable, as my second element to the list. So I define the list as 10, 20, 30, 40, 50, 60. And then I added red as the second element. Right? 0 and 1, that would be second element to the list. Let me connect my notebook. All right. Since I'm not very clear about how far did we go, and you probably don't remember things like either, I'm just going to assume that we covered this, and let's look at this question. And let's do that one, if you haven't done before. Let's work on that one. I'll give you a few minutes. I want you to define a list, right? Just some components there. And then do these. Slicing is important, not because of Python, but when we talk about NumPy, also we are going to come back to slicing and how to get a subset of the data. It comes up a lot over and over and over in any kind of data analysis you do, any tool you use, it's R, it's Python, it's, that's it actually. In SQL, we don't really do that. It comes up a lot, so it's good to be comfortable with the slicing. Now, I put the general structure there. Right, when you do slicing in Python, basically it is you give it a start where you want, if we're talking about just a simple vector, where you want to start the slicing, which part, which element you want to start to take out of your list, and then there is a stop. All right, where to start, where to stop. The only thing about Python is that it starts where you tell Python to start, but it stops one element before stop. So just keep that in mind. That's the only tricky thing about when you're slicing. If I run this, so here I defined a vector, starting from 7, it has 7, 2, 3, 7, 5, 6, 0, 1. And I said I want to print elements starting from 1 to 6. I remember 1 here is the second element because Python it starts from 0. When I say 1, it means it starts from the second element and ends at the 6th element for this list because the stop doesn't count. I know you might say that's very weird of doing it, but there's some computational, calculation, kind of some reasoning logic behind it. I just have to be comfortable with that. Don't make that mistake. All right. Now, one thing about sequencing is that I think kind of similar to MATLAB, if you don't mention anything for start or stop, if you don't mention anything for the start, it starts from the beginning. If you don't mention anything for the stop, it's going to go all the way to the end of the list. Right? So in this case, this was our list. Right? First, I said start from wherever is the beginning of the list and stop at the element 5, because we start from element 5, which is element's fine. So 0, 1, 2, 3, 4, right? The second one, I specifically said where I want to start, right? Which is basically the third element, right? If this is my, where did I put the list? This is my fourth element, and mentioned and said just go all the way to the end of the list. So I think I've seen this in MATLAB. In MATLAB, I think we just use end, but here you don't even need to put end. We just have to leave it as is. Now, negative indices. These are a little tricky sometimes. becomes confusing, right? So in Python, when you use negative indices, basically it starts counting from the end. So -1, -2, -3, whatever you put, it starts counting from the end of your list. Of course, it happens a lot. When you have a huge vector, you don't know what is the length of the vector. You don't want to find the length of the vector and do put that as the end. You can just start from a negative and start from the end of the list. All right. Now, I did one example there. This is a better one. In this case, I said, well, I have a sequence or a vector, you can think of it. Start from, look at what happened there. I said, well, it starts from element -4, right? -1, -2, -3, -4. This is my element -4. Start from -4, go all the way to the end of the list. So I'm counting from the end, but still moving towards the end. It makes sense. Now the second one, I mixed things up. I said, well, start from -6, right? -1, -2, -3, -4, -5, -6. Start from -6. Stop at -2. Now, -2 is here, but we know that we stop one element before the stopping point. Right? So I end up getting this slice of my vector. Does that make sense what happened there? This is a little tricky, especially when you take into account that you don't stop where you tell Python to stop. You stop one element before that. All right. So I did bring this figure here that might help when you visualize how this counting works from the beginning or from the end. Hopefully that helps with two examples there. In this example, I actually typed it here. I said, well, we have a string. If you remember, I said strings are kind of treated by Python as a list. But I converted that into a list using the command list, which will make it as officially as a list. So that's the list. Let me print it. So we have a list similar to what we had there. I just want to remake what this figure tells or talks about. Now, I said, let's slice. If I say slice it from 2 to 4, right? It starts from 2, ends at 3. This 4 doesn't count. If I say slice it from -5 to 2, right? It is sliced from -5, which is -1, 2, 3, 4, 5. Goes all the way to -2, which is 0. But, well, the last one doesn't count, so we stop at the one before that. Yeah, negative slicing, it's very helpful, but also you have to be very careful with that, right? Where it starts, where it ends, and how it counts. Now you can use the stepping, right? You can say you wanted every other or every 3 elements to make it more even sometimes confusing. Step is optional, right? In this case, here's an example I put there. I said, well, this is my vector or my sequence. I start from the first one, or basically 2, because 0 is the first. Start from the second element, go to the 6th element, which is 6th element, right there, 0, 1, 2, 3, 4, 5, 6. There you go. And do print or basically slice it every other element. All right, I put 2 there. If I put 1, as if I put nothing, I will just cut the part that I want from 2 to here. If I put 2, I'm still cutting this part, but I'm getting every other element instead. Now, it depends on what the step is you want to define, of course, every 3 steps, every 4 steps. So you have the options to start, you have the option stop, and you have the option step. If I start from this element, what would be the next step? The one after that, 2 elements after that, 3 elements after that, that would be your step. And you also have negative indexing. So be aware of that, let's put it this way. You might not be comfortable with it. You might find your way of coding. And I have to emphasize that every one of us is going to develop his or her own way of writing codes. Now, of course, there is a best way of coding. There is some standard advised way of coding in Python. but this is not exactly a coding class. So I'm not picky about your codes being the most optimized or optimal version of the code that could be, as long as it gets the job done. We are not very put this way, we are not very picky about the optimal version of the code or the fastest way of doing it. Here and there I tell you which method is faster, but in general, we're not that picky. All right, so let's do this question, guys. I'll give you time. A few minutes you start, then I'll start, and then we'll check. All right. We talked about tuple, list. We'll come back to these. We're gonna use them a lot. But one structure that we're gonna use way more than probably everything is dictionaries. Now, dictionaries are when we start talking about data frames in pandas, you will see dictionaries come up over and over. But for now, dictionaries basically are containers, or a dictionary is a container with a set of key and value, right? Can think of it as the key is a key to some values, right? Key is just one variable, could be a numeric, could be string, and I think it could be a non. Never use the non as a key. Values could be also anything. Could be numeric, could be a list, could be a tuple, could be a list of lists, could be a tuple of a list. So every combination we talked about could be a string, could be a list of strings. Now, the importance of dictionaries, is going to be more clear later on that when we start talking about when we start playing around with data sets. But we can think of a dictionary as a table. We can think of each key as one row and the values as, well, I don't know if I have to refer. So you can think of the key as an observation. Right? Let's say you have a list of names with different people's names with some characteristics, right? Color of the eye, height, weight, whatever you want to record for that person. And I can think of the name as the key. Think of those characteristics or features as values. Typically, that's how I think of a dictionary. Another way of thinking of a dictionary is a phone book. You can think of each page of a phone book as the key. When you open that page, and in that page is a list of phone numbers, right? Those are values. Now, as I said, values in a dictionary, in this case, let's start with this example. So I defined an empty dictionary. Now, we defined tuple with parentheses. We defined the list with brackets. Now we are defining dictionary with curly brackets. Now, dictionary has two components, a key and a value. At least it needs a key and a value separated by a colon. Now I can have multiple of them. I can have key here. The key is A. The value for A is some value. Some creativity from my end. Key B has the value of a list. And then the third key is just a number. 10, its value is test. So I was just trying to show you can use different variable type as keys. Now, if I print, I print this, you basically see your dictionary. Now, the way you access to dictionaries contain or whatever is in the dictionary is through the keys. Right? That kind of name says it a little bit. You use the key to open a door to some values or some space. Right? You use the key to find out what are the values assigned to that key. In this case, I say I want to see what is under, what are the values for the key C, sorry, let me go back, do it separately. D1, and let's say the key is A. If I print that, right, I get some value. I see the value for that key. Now, dictionaries are like lists. We can still modify them. And that's what I did here. I jumped the gun. That's what I did here. I added a new key with some values, right? My dictionary had key A, key B, and key 10, with each one has its own values. One is a string, one is a list, one is just another string. Now I'm adding a new key, key C, with some values as a list. Now, one thing that changed in Python before, I guess, a few versions ago, if you print a dictionary, if you were printing a dictionary, the order wouldn't have been the same order as you put things in. But now it's the same order. But in general, dictionary doesn't have a sense of order the way the list and tuple have. Right? You can't say, I want the first element or second or third element in a dictionary. It always works with keys and values. All it cares about is what are the values assigned to this key. So if you want to see those values, give me the key. It doesn't care. It doesn't have a sense of where it is. Is it the first one, third one, or fourth one? All right. So just have that in mind. Keep that in mind. Now, the good thing about dictionaries is that you can, like lists, you can put everything in it. Right? As I said, the values can be a list, can be a tuple. I didn't put a tuple here, but could be a tuple, could be a string or list of a string, anything you want. Now, a couple of things about dictionaries, similar to lists, as I said, you can modify them. Right? You can delete an element, a pair of key and value, and keys and values come together. Remember, when you delete a key, you are deleting the key and value. There is no value by itself without a key. Right? So you can delete any key value pair in a dictionary by just the command delete or del. Right? It's an example there. I define these keys and values, and I define the key 3, and it's gone. Now, one way is using del command. The other way is use the pop method. Now, the only difference between pop method and del command is that when you use pop method, it's going to keep what you deleted. So you can actually get that as an output. So you can say, I want to keep the deleted value. Delete it, but just keep it somewhere for me. Right? So you can actually have that value stored if for any purpose you need. That's the only difference between pop and del. If you don't want to keep that, you can just use delete del and delete the key pair, value pair. If you want to keep the value, use pop. Yeah, you can get a list of keys and values in a dictionary, right? If you're given a dictionary, you can just use method keys and values. You can use update. Update is similar to extend for a list, right? If you want to add, let's say another dictionary to the dictionary you have, right? A bunch of keys and values. Just use the method update. And the dictionary you had from before, if I see my dictionary right here, if that's my dictionary, I'm going to update that with key 5 and key 6 with these values, right? This comes up a lot in, I think maybe briefly you saw it in first class when we're talking about logical operations. Now, what it does for you is it looks into a list or a tuple or some structure and tries to find out if what you're looking for is in that list or tuple or dictionary or whatever you do. Let me do an example before we get to this in dictionary. Let's say I have a list and has 1, 2, 3, 4, 5, 6 in it, right? Now, I can ask, let's define this list. I can ask whether 2 is in this list. And the result is true, means yes. You can ask 7 whether 7 is in this list. That would be false. So in is the output of in is a Boolean variable. Right? So you can make a quick search in your list or tuple or whatever you're looking at. Here is just the way of searching the dictionary. Right? So in so many cases, the dictionaries you get are very large dictionaries. A lot of keys, and each key has its own values. We'll talk about arrays in 2D, 3D. In so many cases, you might want to search to see if a specific key is in the list of keys. Right now, it could be list of people. You have a lot of names, and you want to quickly check whether or not this specific name is in your dictionary. Just use the name in the name of the dictionary, right? It's a pretty handy command, and that's why I just brought it here. So I want you to create a dictionary. Use your first name as a string 1, use your last name as a string 2, height and weight, and do what I asked you to do. Just playing around with dictionary. We will not talk about set. I put a list there. That's actually a pretty thorough article talking about sets. Sorry, I said list. Sets. If you end up using it for any reason, or you see it in a code, feel free to take a look at it. Right? It's not something that we typically use, or I personally don't use. But as I said before, quote from an experienced programmer, he believed that sets are underutilized. We just follow the trend, I guess. Let's talk about functions quickly, and then we'll talk about NumPy. Let's see how it goes. So functions, the general format in Python, def is the part of the syntax, name of the function, the input arguments, and whatever you want to return at the end, and whatever you want to do inside the function. Now, as I said before, Python's way of figuring out if you are within a function or a for loop or if structure or anything like that is indentation. So this indentation here, it's pretty important, you know, and it depends on the setting on your notebook. You might get 2 or 4 indentations. I create these notebooks with 2 indentations, but you can always change it to 4 if that's how you're more comfortable programming. Right? A lot of people I know, they prefer 4 indentations, 4 spaces, sorry, for the indentation. So I guess it gives them a more clear separation. So very simple function, right? Takes 2 inputs, A and B, multiply them, it returns the result. You can just call the function and then put the whatever the outcome of the function is or whatever it returns to some variable and print it. Now, one thing about functions that it's pretty handy to do is defining positional or keyword arguments, or in an easier way of, the better way of talking about it is that whether you're going to give a default value to some input argument or not. So here is a case of that. For that, I said I want this function to have 3 inputs. X and Y should be given by the user when they call the function. Z, if they give it, they give it. If they don't, take the default as 1.5, right? And you can do whatever we were doing before in the using control flow in a function, right? I just put a simple if function, if else structure there. Now, the reason I brought this here because I want also to emphasize, I think I mentioned that there in the notebook, that a function can have multiple returns, Python. So you don't have to have just one return. You can have multiple return, whichever that comes first, basically, that is going to be what the function returns. Right? So you can have as many as you want. Some examples of calling this function, right? As I said, you can specify Z, whether or not saying Z is equal to, or just give it a number, or you just don't even have to use Z as an input and just let it be the default value. Now, a good way of one good thing about Python is that you can change y is equal to 6, x is equal to 5, and z is equal to, let's bring it to the beginning. All right, let me separate these so we know what we're looking at. As long as you mention the input arguments with names, you don't even have to follow the same order. All right, you can just say, I want this z to be this value, x to be this value, y to be this value. If I mention them by name, the order doesn't matter. So you can just do it the way you want. That's kind of handy, and a lot of people when they call functions in Python, they code by using the names of the variables or whatever the input. All right. One thing is a general thing that just to be careful about. I brought two examples here just to emphasize about local and global variables. If you've done programming, you already know that. Right? If you define or declare a variable as a local variable within a function, that variable does not exist outside the function. And if you declare a variable as a global variable, meaning it's, let's say in this case, outside the function, then you can call it within the function or outside the function. So just be a little careful about that. In this case, I defined this or I declared this variable, I called a local inside this function. Right? I call the function and I try to print this variable, but what happens is that you're going to get an error by running this, right? It says it's not defined because it's only defined within the scope of the function. So be a little careful about local and global variables. Now, if I define as a global variable and I change it or add some values to it in this case, or modify it within the function, and I print it, right? Outside the function, I still get the updated value because it's defined as a global variable. You can return multiple values for a function. All you got to do is just return it as a tuple. Okay? You still use one return. Put everything you want to return by that function you want to be returned, just put it in a tuple. Right? In this case, I just use 3 inputs and I return 4 outputs. I put all of them in a tuple. And if I call that function, let me take these out and I just run this part. If I run that function, given 1, 2, 3, I get all my outputs in one tuple. All right, all those values. Now we talked about unpacking the tuples when we're talking about tuples, right? If you want every single value separately for some specific purpose, you can just unpack that tuple. Values is a tuple. You can just unpack it to 4 different, maybe better if I use different names. So they don't have to be the same, just, var3, var4. And then you can treat them as different values. Just in case it comes up frequently when you have a function and you want to return multiple things. Just put it in a tuple, return it. If you want every single value separately, just unpack that tuple and use whatever value you get you want for the rest of your calculations. There are anonymous functions, or they're called lambda functions in Python. I'm not going to talk about it here. I'll put a link there if you want to look at it. They are very handy if you just want to do some specific calculation just once. You can just define a lambda function. They have their own syntax. Feel free to take a look. That's a pretty good article there. It takes you step by step. How do they work and how are they defined? You might not end up doing that often, but it's good to take a look at the structure if you see it in a separate code or a different code to be familiar with the whole idea of these anonymous functions or lambda functions. All right, let's do this question. I think it's straightforward. Write a function that takes 3 numbers, calculate the summation of these numbers, and return all the numbers with the summation value. So just give it a shot. Use the function syntax. You have 3 inputs and you have 4 outputs, right? Those 3 numbers plus the sum of those 3 numbers should be returned. Maybe I should have added to print it, but if you don't, that's fine. Feel free to expand it a little bit. Unpack the tuple you get as the return, and then print every value when you unpack the tuple. 3, 1. One. Expected. What did I do? Punch. Plus 4.